In this video, I'm going to be forging the jaws on the tong blanks that I laid out for you in part 1. So in this video, we're actually going to be making tongs. Hi, I'm Dennis Frechette, and welcome back. This is part 2 of a two-part series on forging tongs. In part 1, I laid out how to forge out the actual tong blanks, which are basically the reins with the material that you're going to need to forge the jaws. And in this video, I'm actually going to show you how to forge the different types of jaws that go into making the various tongs that you're going to need. If you haven't seen part 1 of this video, you can check the description. The link for it is going to be in the description, as well as the other reference videos that I have in this series that are currently available. As new videos become available, I'll be adding them to the description in all of the reference videos. So if you find one, you'll be able to check the description and you'll get a link to all the other videos that are currently available. Hope this helps you out. So here is a typical example of where you should be at this point. If you're looking at the tong blanks from the top or the bottom, they should have a fairly consistent profile right from the hinge area down to the end of the tongs. When you turn them to the side, you should see the widest part of the reins up near the hinge area and then sort of a long gradual taper going down to the tip. When you turn the handles to the side, you'll notice that the area closest to the hinge is actually rectangular in shape, and then about a third of the way down, that kind of transitions into more of a square cross section that's about even to the thickness of the reins. When I gave you the dimensions for the handles and the plans that I provided, I just laid them out as two pretty simple blocks. And I did that because when I'm roughing out a shape, I find it easier to keep track of a series of square blocks. And then once I have those in place, I can do whatever I have to get the final shape that I'm looking for. One approach that I use quite often is to forge the bar section at the beginning of the taper and then the bar section at the end of the taper. And then I work my way towards the middle. I decide at the time how best to do that. But basically, I'm keeping in mind that the heavier bar section is up near the hinge area. So I'll forge that as a heavy cross section. And I'll start at the other end with the square bar cross section. And I'll work towards the heavier bar section and decide what kind of a transition I want to make between the two. Regardless of how you decide to approach it, the important thing at this point is to make sure that you have the proportions right. Once you have that, you can go ahead and decide how you want to shape the reins. They don't have to stay square. You can shape them any way that you like. Here's a pair of tongs that I forged several years ago using essentially the same pattern. I forged the hinge area a little thin on this pair, but the handles follow, the guidelines that I've set out for you exactly. They're a nice heavy set of tongs. They have some good flex to them, and I've just rounded off the corners enough to make them comfortable to use. That's really all you need to do at the bare minimum. This rectangular cross section is really effective. Here's a closer look at the narrow flat jaw tongs that I use quite often in my videos, and you can see how the overall design is pretty much the same. I've just forged the profile down a little bit thinner to make them a little lighter and easier to handle, but there's still a fairly substantial set of reins for the size of the jaws that I have, and they are really comfortable and easy to work with. Don't forget that your hands don't change size just because you've decided to forge a smaller set of jaws on a pair of tongs. So, in my opinion, there's a limit as to how small you can make a set of reins on a pair of tongs and still have them functional. And here's another example. This is actually the first pair of tongs that I ever bought almost 50 years ago, and it has the same profile, but it's going in the other direction. This is actually pretty light for the size of jaws that it has. So this is at the other end of the scale. I certainly wouldn't use these for heavier forging, but they are nice tongs to use, and they were the inspiration for the way I make tongs right now. It took me a long time to figure out how these were made. And finally, here's an example of how that rectangular cross section was actually forged right back down to round bars. So however you approach it, you decide what you want. Obviously, this is why you started blacksmithing, to make things that you want. But the important thing is to keep that cross section heavier near the jaws, tapering down to a finer end at the end of the reins. And as long as you keep those proportions and stay a little bit on the heavier side, you'll have a good set of working tongs that'll last you a long time. The last thing that you need to do before you start forging tongs is to run a few tests on the numbers that I've provided for the jaws. These numbers are just estimates based on how I forge tongs. In most cases, they're overestimates. They're like the most amount of material that you would ever want to use for a jaw of that particular type. At any rate, you need to check them out. So the safest way to do that is just to take a square bar, set up your ruler on your anvil, and just start forging out sample pieces and see how it goes. You may find that the measurements are okay, and that's great, but chances are you're going to find that they're either too short or too long, and you need to be able to adjust that. So working on a scrap piece is the easiest and the safest way to do that. Once you've established what you want to work with, then you transfer that measurement to your actual tong blanks, and you forge out the pair of tongs as you want them. And the most important thing that you should be getting in the habit of doing is just writing this stuff down. If you make a change to something, document it, write it down, create a chart. Even better, make sample pieces that show the process, that you use to forge something. Whatever it takes, document it so that, if you need to visit this in 6 months, a year, 10 years, whatever, you have a formula to work from, because trust me, you're not going to remember this stuff. In this example, I'm forging a narrow bit pair of flat jaw tongs, which is a pretty common variation, and I have that illustrated in the charts. I recommend it starting with 1.5 inches. For this example, I decided to use 1 inch just to try it out, and I actually think I like it better than the size that I had quoted in there. So, these are my notes. So you can see how things change over time, and, you need to document it. And if you make a change, definitely write it down. Flat-bit tongs are the most basic form of tongs out there. They're basically just long-handled pliers, and as the name suggests, they have flat jaws, so they rely solely on clamping pressure to hang on to the work. I don't recommend them for forging, but there are a lot of other jobs in the shop that require handling material, especially hot metal, and flat-bit tongs in all their different shapes and configurations are perfect for that. The two halves of the tongs are going to be held together with a rivet. It's quite common to drill a hole here, but I always punch a square slot and then drift it round to fit the rivet that I'm using. When you punch a square slot and then drift it round, that automatically shapes the hinge area into that circular round boss that everyone's looking for. Here I'm just using a fairly low heat to set up the chisel. What I want to do is just create a slight depression that I can find easily when the hinge area is at full heat. In this case, I've punched the hole a little bit off center, but I can still fix it because the hole isn't very deep, so I can just create a new punch mark that's a little bit over and then set that one in. If I like the location of that, I will use that location to drive a deeper hole that I can follow when I'm punching. Now that I have the punch mark back on center, I'm going to drive that mark a little bit deeper, and that'll be the mark that my punch will follow when I'm actually driving it right down to the anvil. So in this heat, I'm going to be driving the punch in as far as it'll go, and it'll feel like it's hitting the face of the anvil, but it's actually up a fair amount because the metal is cooling the whole time I'm driving the punch into the metal. So I'm going to take another heat and reinforce that hole and drive the chisel right down to the face of the anvil, and this is going to leave a paper thin slug that I'm going to shear out here in a moment. So this little tiny piece of metal is the only thing that I removed from this hole. Everything else got pushed to the sides. So to shape the square hole that I just punched into a round hole that's going to fit my rivet, I'm going to use a tool called a drift, and this one I've modified for this purpose with a slight taper on the tip so it'll fit the square hole, and then as I drive it in I'll get different sizes of round holes to fit whatever bar stock that I'm using. The plate that I'm hammering on is called a bolster plate, and it just has a series of holes that allows me to support the edges of the work while I'm drifting it. And here you can see how the drifting process really refined the shape of this hinge area without any additional forging. It's important not to get the hole too large so the rivet just slides right through, but I'm trying to get it tight enough so that I can use this half of the pair of tongs to hang on to the rivet while I'm joining the two halves together. And the next step in the process is to do the whole thing all over again to make the other side. And this is where your notebook, if you decide to set up a notebook, is really going to start to pay off, because a few seconds here and there measuring, making sure that you're on track is really going to save you a lot of time in the long run. And it's really frustrating to spend an hour, 2 hours, 3 hours working on something and realize that you've messed it up because you didn't bother to take 5 or 10 seconds to measure to make sure that you were heading in the right direction. formula for the rivet length is pretty standard. For a two-headed rivet, you need to add 3 times the diameter of the rivet to the total thickness of the material that you're riveting. That may seem like a lot, but trust me, this stuff really starts to disappear as you start hammering it. And if you go any less than that, you're not going to have enough. When you're riveting, I always use the lightest hammer that I can find. I think this is about a half a pound, which is, roughly 250 grams, I guess. But the important thing is to use a light hammer. A light hammer, the effect of the hammering dissipates very, very quickly on the end of the bar. It doesn't have enough drive to really penetrate into the bar. So that pushes the bar back in on itself very slightly. If you use a hammer that's too heavy, it's going to have way too much driving force, and it's going to tend to bend the rivet, which is really catastrophic at this point. At the very least, it'll take a lot of time to get that rivet out of there, and if you happen to hit it a couple of times too many, you may actually wind up damaging your tongs trying to get that rivet out. So it really pays to take your time here. Use a light hammer. Work on one side, flip it over, work on the other side. Once the rivets are starting to set, then you can go to a heavier hammer, but always start light. I usually set my rivets in a couple of different stages. The first stage is when the rivet compresses enough to force the two faces of the hinge area together. I'll separate that, loosen up that joint, and then I'll drive the rivet a little bit more, loosen it again, drive it a little bit more, loosen it again, and that basically will fit the faces as closely as possible to each other. You can normally work through the whole process in one heat, but sometimes the rivet's a little stubborn or the faces have a little bit more irregularities that you need to work through, so several heats may be necessary. And the final stage of the process with all the pairs of tongs, and I didn't film it unfortunately, I apologize for that, but it's pretty straightforward. You just put the bar stock that you plan on using with these tongs in the jaws, and you hammer the jaws down to the bar stock, as well as make any adjustments that you need to get the tongs working properly. Heavy ring tongs are a pretty simple variation on a pair of flat bit tongs. I always forge them with really heavy jaws because I use them mostly for holding big punches or set hammers, things of that nature, things that take a lot of pounding. So you want absolutely no flex in those jaws. You want a good tight grip. You don't want anything moving. You can set up the basic shape of the jaws over the edge of the anvil or on my portable bar swage here that I've made up, but the final shaping should always be around the actual bar stock that you're using for the punch. You want absolutely no gaps around this, so you need to have a good tight fit. To complete the tongs, you make another jaw that's exactly the same as this one, and you rivet the two together the same way you did the flat jaw tongs, or any of the tongs for that matter. I forge my small ring tongs very differently from my heavy ring tongs. I use a long, narrow set of jaws to forge these, and I'll place the curved sections that hang on to the rings right at the very end of the bits. The longer jaws allows me to grip a wider range of sizes of chisels or punches, and that's fine for the lighter duty chisels that I'm going to be using with this. The other variation that I did with this pair of tongs was that I made one jaw curved to hold on to chisels, and the other jaw was left flat, pretty much the way I'm going to leave it this jaw right now. And that was very useful for hanging on to very small chisels or for reaching into the fire to pick up stuff. The flat jaw didn't push away as much material, so I was able to reach in, grab the work, and pull it back out. However, ring tongs are normally made with two curved jaws. The flat jaw was just a variation that I came up with. I don't think I've ever seen anyone else do it, but it was still useful and I would still use it. Box jaw tongs are specifically designed to hold a flat piece of bar stock. One jaw is shaped like a standard flat bit pair of tongs, and the bottom jaw is modified so that it curves around the edges of the piece. So this is a very secure way of holding a piece of flat bar because the flat bar is totally contained on all four sides. In this example, I'm able to forge the box side of the jaw out of one piece because it's meant to hold narrower strips. Later, I'll be demonstrating how to forge larger box jaw tongs, and with that, you are going to need to join two pieces to make the jaws. So here I'm starting to work on the other jaw, and this is the bottom jaw, and it's the one that contains the box that's going to wrap around the bar stock that I'm using. You'll notice that I've started by creating an offset right at the very end of the bar, and I'm leaving the full cross section of the bar there. I'm going to need every bit of that later to form the box. The rest of the jaw is just hammered out like a regular flat bit pair of tongs up until you reach that offset. Here I've switched over to the cross peen and I am spreading that material as far as I can. I don't want to make it too thin, but I want to get as much width as I can. And here you can get a quick idea of how these jaws are going to fit together. And here once again I'm going to be using my bar swage to set up this corner for the box. There are a lot better ways of doing this, but if you don't have that stuff, this is a pretty simple way of getting the job done. The fuller that I'm using has a nice round radius, so I'm not going to be putting any sharp creases in the corner of this box that can weaken it. The top jaw for the large box tongs is forged exactly the same way that you would for a regular flat bit pair of tongs. There is a variation on this where you take that shape and you curve it so that it can reach around something like a hinge barrel or any other obstacle that might be on that flat bar. But generally, the most common ones that you see have a flat jaw on the top. The bottom jaw starts off the same way, but this jaw is going to be modified to accept a crossbar that's going to form the box for this jaw. So depending on how you're going to do that, you need to make adjustments to the bar length that you're using. When I'm forging box tongs, I usually forge both jaws the same way, only the bottom jaw gets modified so it wraps underneath the bar that I'm going to be using as the crossbar for the box. I actually like the look of it, and it holds everything in place while I'm welding it. The other added advantage is that I'm not much of a welder, so the more weld that I can put on something, the better. Here I'm a little bit further along. I have the bar steel that I'm using for the box welded to the bottom jaw, and I've taken an angle grinder to smooth out the welds as much as I can. Here I've just taken a heat and I'm using a hammer to flatten everything out and straighten it out and make sure that the inside face of that jaw is perfectly flat. And this jaw is actually wide enough that I can use the edges of the anvil to do the preliminary shaping of the box. Here again, I'm just rough forging the shape of the box at the anvil, and the final shaping is going to be around the actual piece that I intend to hold with this pair of box tongs. Pickup tongs are a pair of tongs that get used for a little bit of everything. Every blacksmith has their own design for this. The ones that I prefer are these long, slender, curved jaws that I'm going to be forging here. They get used to, literally pick up stuff off the ground if it happens to be hot and you can't reach it, reach into tight spaces that you can't reach, or reach into the fire to get something that might have fallen down towards the bottom of the fire pot. You can't reach it any other way. Pickup tongs are great for just getting into all those little spaces that are a nuisance. Here I'm starting to forge the second jaw, and this one will take me a couple of heats more than I did the first one, because the first one was just freeform. I just shaped it out by eye and there it is, but this one I have to match the first one. So I'm going to take the time to start measuring all the key points as I go along. Here I'm comparing the depth of the offset before I move on. Now that I have that reference point established, I can go ahead and do some forging. I have quite a ways to go before I have to worry about how close I'm getting to the original. I've set these dividers earlier to the total length of the first jaw. So I can see that I have a little bit of refining and I'll get the length that I need. So at this point, I'm going to proceed very carefully. I'm not going to be too aggressive. I'm going to make my changes very slowly. The last heat was a little bit short, so I got a little aggressive here and I overcompensated, and I'll wind up a little bit long on this heat when I compare the two pieces together. Sometimes that's all it takes to throw something out of whack. Fortunately, this time it's a pretty easy fix. Here I'm quite a bit further along. I've followed the same process that I used for riveting all the other tongs, and the reason I'm showing you that here is because this is a type of tong that is much easier shaped after the two halves are assembled. Here I'm forging in a pretty large gap right near the hinge area, and that's going to allow these tongs to open up and reach around some fairly large pieces of metal. These jaws are very straightforward and simple to forge, and the jaws are identical and symmetrical when they're straight. However, to get the jaws to line up when they're bent, they need to be bent in different directions, and that can be something that you lose track of very easily when they're working with separate pieces. So I always assemble the tongs and then bend both of them as a unit. And of course, these tongs are designed to grab and pick up just about anything that you have around. And finally, we have the bolt tongs. These are probably my favorite tongs. I've mentioned that many times, but they are the most versatile. You can hold round stock, you can hold square stock. The large loops in the openings allows you to have curved pieces running through there. So they can really hold quite a variety of bar stock. The small bolt tongs are forged exactly the same way as these pairs are. They're just using a smaller bar stock to start with and smaller dimensions, obviously. The setup is very similar to the lower jaw of the small box tongs. You're creating an offset on the end to isolate that amount of material that you're going to be using later to actually forge the working part of the jaws. The rest of it gets forged into a large loop, so that just gets flattened out and drawn to a very specific length. And these tongs, it is very important that you make notes and you refer to those notes often to make sure that the two loops look symmetrical when you put them together. Measuring is the only way to get these right. And once again, for this pair of tongs, you forge another side that's identical to this one and you rivet the two together.